for today. Okay, so all right, so we're going to do some applications today with exponential growth and decay. All right, the first place where this stuff is really useful is in compound interest, right? Compound interest is a way for the bank, when you've invested money, to pay you interest. And the thing is, like, when you do have some money in the bank, you get a statement every now and then, right? Like every 3 months, every month, every whatever. And then, however much money you have in your account at that point, they give you interest on it. Okay. So the formula for this, for compound interest, is this. I'm sure you've seen it before. So basically it's A equals P, 1 plus R over N to the NT. And you do have to memorize this for the test. So here are some of the variables that are used in the compound interest formula. A is the final balance in your account. So when you get your statement, how much money you have in the account at that time, right? That's your, that's A. P is the principal, right? We call it principal, but that's not Miss Howard. That's the money you go to the bank with, right? When you went to the bank, how much money you had in your pocket to invest, that's the principal. So it's the initial amount. R is the rate in decimal form. So you have to divide the number by 100 to get the decimal version. T is time, usually in years. N is the number of times within a year that the customer is paid by the bank. And this is something that is provided in the formula, in the problem itself. And it depends on like the specific type of account. Okay? Okay. So, all right. So take a look at this. So Tanya invested $2,000 into an educational account at a 5% interest rate. Yeah.
It never says that someone is getting paid bi-weekly. We've been having this discussion.
Okay, let's do that later.
Is it 2 times a week or is it 2 times a month?
Month.
It'd be a month.
Yeah.
If it's bi-weekly, it's not by month.
Yeah. Let's do this. Okay. Yes.
So they made a whole
Account 5% interest rate. If Tanya does not make any other deposits or withdrawals, what will be the account balance after 18 years? If the interest is compounded, quarterly, monthly, or daily. So this is too many words. So we go back. Okay, so this person invested $2,000. What quantity is that? The A, the P, the R, the N? The P. So P is 2,000. 5% interest rate, so R is 5 over 100, right? Which is 0.05. What will be the account balance? So we're looking for A. A is what we're looking for, and T is 18. Okay? If the interest is compounded, now, quarterly, monthly, or daily? Yeah. So if the interest is compounded quarterly, that means it's happening 4 times a year. So N is equal to 4. Monthly, N is equal to how much? 12. And daily, 365. So what we're going to do is we're going to do like, A, B, and C here. So for part A is P 1 plus R over N to the power of NT. And so A is 2,000. 1 plus 0.05 over 4 to the power of 4 times 18. Okay, so let's go ahead and plug this back in. Let's plug this into the calculator. So we're going to do 2,000, 1 plus, exactly as you read it, 0.05 over 4 to the power of, 4 times 18. Okay? And that should give you this much. Okay? So $4,891.84. What was it? I lost it too. 4,000. So let's make sure that all of these numbers are exactly as we wrote them here. Okay? Okay. So look, let me say one thing. How to round. You should know the place to round. So this is dollars and cents. So you should go to 2 decimal places. And you have to round correctly. So 84, not 85, and so on. Okay? Now, for part B, the only thing that's changing is n equals 12. So we're going to rewrite it, right, for part B. A is going to be 2,000. Please show me this step, and then you don't have to do any more. Over 12 this time, to the power of 12 times 18. Okay? Now, when you go in your calculator to plug that in, here's what you're going to do. Press the up button once, twice to highlight this, and then press enter, and that gives you the same thing in editable form. So then keep pressing the right or the left arrow button to go in there and like delete the 4, put in the 12, but make sure you do it on the bottom too. Yeah, so you should get this. So you're going to go press up once, twice. Once you highlight that, you press enter. It would give you how much? $4,910 and how many cents? And 2 cents. Good. Okay, so we're on to something. This one, because we're getting paid 12 times a year versus 4, look at how much more money we have over the 18 years. How much more money do we have? It's like $19 more over the 18 years, right? We're on to something. So let's do this one, C. A equals 2,000, 1 plus 0.05 over 365 this time, to the power of 365 times 18. So A is, okay, so go ahead and edit, and let's see what we're going to get. You remember how to edit? So 365, 365, okay, 4898 and 90 cents. Okay, so a whopping $8 more than the previous one over the 18 years. Okay? So, okay. So now, what if? Oh, what did I say?
Yeah, I got 4918. Yeah.
Oh, what did I? 4918. Where did that come from? Okay, too many nines and everything. Okay, so that's what happened if, n was 365. Now, what if you're not paid 365, you're not paid like once a day? What if the bank said, you know what, we're going to pay you continuously? So like every nanosecond. Hey, so let's do that later so you don't miss this. I promise I'll help you with the calculator in a bit, okay? So what if the bank said, you know what, I'm going to pay you every nanosecond of every day, okay? What happens then? Then, how many times are you being paid in a year? An infinite amount, okay? So we say this is continuous compound interest, okay? And the way it's written, it says it's compounded continuously, okay? It's compounded continuously. Those are the words you need to look for. You need to look for the words compounded continuously, and then there's a new formula, and it's this. A equals PE to the RT. Okay? All right. So This Tanya person found another account that says 5% interest continuously on the $2,000 investment because they were on such a roll over here, right? So they're like, okay, imagine how much more money I'm going to get then. So let's see. How much are we going to get after 18 years? So now A is 2,000 e to the 0.05 times 18. 2,000 e 0.05 times 18. Here we go. 4,919 and 21 cents.
Don't forget about the formula.
Well, clearly they didn't put that in the $2,000 investment. So, you know, like another $1.09 more, right? So that's how we use that formula, okay? And this is the APERT formula, it's the Purdy formula, it's the whatever, okay? But you have to look for the words continuously. Okay, so going back to Max's question, is this really just for this? Well, no, this is just one application of where we use these formulas. In addition to investments, other fields also change at an exponential rate, okay? Like population, yeah.
So was that E in the last problem, like the number?
The E, yeah, 2.718 E. Yeah, there's only one E. Yeah. So what are some other things? So like populations of people, populations of bacteria, animals, radioactive material, half-life, these are all, you know, the same sort of deal, okay? So, okay. So when it comes to these formulas, the book that we use uses like different letters than how we see it in like everywhere else. So I've given you both versions. Okay, so what we have here is this. So in math, in order to be efficient, if you have final amount, suppose final amount is n, initial amount of that is written as n sub 0, but we read it as n naught. Okay, so n naught, y naught, p naught, v naught, okay? So it's like initial versus final. So that's, you know, a little bit of notation. So if final is n, then this is initial. Okay, so if an initial quantity grows at an exponential rate or decays at an exponential rate, these are the formulas. So when it just says it grows or decays at an exponential rate, this is the one. This is what we're going to use. So this is the formula, this is the version of the formula the book gives. They use n's. N equals n naught 1 plus r to the t. Or everywhere else, we use y equals y naught 1 plus r to the t. Okay? And then, if it's growth, r is positive. If it's decay, r is negative. Okay? Now, when you hear the word continuously, then it's n equals n naught e to the kt, or y equals y naught e to the kt. Okay? So, k is the same thing as r, but when we use this formula, we normally use k instead of r. Okay? So k is like the continuous rate, and that's like the rate in the other one. 0.05, yeah. Okay. So again, here are the, here's like a little legend. N or Y is the final amount. N naught, Y naught is the initial amount. R or K are the same thing, it's the rate. Oh, T is time, I don't know why there's a tab there. Okay? All right, so let's do this one. And then we can tackle some more like homework problems. Okay. A state's population is declining. People are moving out at a rate of 2.6% annually. The state currently has a population of 11 million people. If the population continues to decline at this rate, predict the population of the state in 15 and 30 years. So first, let's go ahead and list what we have and what we need. And I'm actually going to use y instead of n. I'm partial to the y. Just because that's how it is in upper level math as well. Okay. Okay. Okay, so a state's population is declining at a rate of this. So K is, okay, so it should be 0.026, right? But since it's declining, we're going to put a negative in front. Okay, declining, decreasing, whatever, okay? The state currently has a population of 11 million people. This is the why not. Okay, and I'm just going to write 11 million in words. I'm going to save all of those zeros. Okay? If the population continues to decline at this rate, okay, so hang on. Before we start this problem, did we read the word continuously anywhere in this problem? No. So we're going to use the first one, right? So I'm going to call this R. Okay? But, yeah, but it doesn't say, okay, it should have said is declining continuously. Okay. Right? Continuously. Huh?
Would it be wrong?
No, it wouldn't be wrong. It won't be wrong, but I'm just trying to be consistent. Okay.
So it's why this one's why not?
Yes, this one's why not, because it's the initial amount. If the population continues to decline at this rate, predict the population, so we're looking for Y. And in part A, T is 15. Okay? Okay. Yeah, I can zoom in. So, Y equals Y naught 1 plus R to the power of T. So, Y equals 11, 1 minus 0.026. I'm just going to write it as 11, knowing that it's in terms of millions. So 1 minus 0.026 to the power of T is 15. So we go ahead and we plug that in here. So 11 times, what was it? 1 minus.
Oh, you don't have to plug like for 11.
No. It saves like, because, oh my God, you can run into like so many. Remember, like imagine you're stressed and you're like, okay, 1 0, 2 0, 3 0, 4 0, right? So this saves us a lot of stress. To the power of 15. Okay, so 7.4. So what is this? Like there are 7.4 people left in the state? No, it's 7.4 million, okay? So Y equals 7.4, so you say 7.4 million. Okay? Now, obviously, like if on a test or a quiz or a homework or whatever, you wrote 7.4 versus 7.4 million, like that can't be full credit, right? Okay. So for part B, what's the only thing that's changing? T is 30, so it's 11 times this to the power of 30. And again, all we're going to do is modify the 30 from the 15. So Y, oh, how much was it? 4.99? Yeah, 4.99. So it depends on like whether it says to write, like to round to what decimal place. Okay? Okay. Now, and then you always want to like double check, right? Does my answer make sense? So we started from 11 million people and the population is decreasing, right? So, okay, so it makes sense that we got a smaller number and then an even smaller number, right? So like if you had gotten, let's say, 17 million for this, you would have known that there was something wrong, okay? All right, are there any other homework questions we can go over from this set? Yeah.